Good day to my fellow attendees to this 2024 International Conference on Computing. I am presenting our work on the development of an RFID-based record management web portal for goats towards precision livestock farming. And we are from the Central Luzon State University in the Philippines. In this presentation, I will be discussing the rationale of our work, the methodology, results and discussion, conclusion, and future work. So, population growth is steadily increasing worldwide, leading to a greater demand for food and economic resources. As the population grows, there is a projected increase in demand for animal-based food products. So the small to medium-sized local livestock production is emerging as a more sustainable option to meet this demand. An important aspect of livestock production management is the quality of life of the livestock. Maintaining this quality involves practices in feeding, breeding, disease control, and overall animal welfare management. Traditionally, livestock farmers have relied on experience and instincts to manage their herds. Direct animal observations by farmers are used to detect health and welfare issues. Pen and paper documentation, along with spreadsheet applications, have been used to log observations and livestock management activities. With larger herd sizes, these traditional methods become time consuming and labor intensive. Precision livestock farming technologies are now being explored and implemented in these practices, allowing farmers to monitor large populations of animals, detect issues with individual animals in a timely manner, and even anticipate problems before they occur based on historical data. So, in this paper, we introduce an RFID-based record management system designed to keep track of individual goats within a herd from birth to death or from birth to sale of an individual goat. The system comprises four major components. First is the animal identification and data capturing component, which reads the RFID tag of a goat and collects individual data. Second is the task management component, which schedules and records routine herd operations such as milking, weighing, vaccination, breeding, health treatments, and feeding. The third is the financial management component, which handles the sale transactions of livestock. The fourth is the reporting and data analysis component, which generates relevant reports and insights. Our work is tailored to fit the processes and requirements of the Small Ruminant Center, a research center at Central Luzon State University, intending to simplify and streamline their record management. We integrated the structured approach of the waterfall model in the early phases, that is, requirements analysis and design, with the flexibility and iterative nature of agile in the latter phases, that is, construction and testing. So, this hybrid approach allowed us to maintain a clear overall system design while remaining responsive to user feedback and the changing requirements. The figure shows the top level architecture diagram of the system, illustrating how various components interact. We created top-level diagrams and technical designs, including the wireframe diagram to depict the fundamental structure and components of the system's user interface, along with the navigation and key elements, flowcharts for each primary function offering step-by-step visualization of the processes involved, use cases to visually represent a high-level view of the functional requirements and interactions from the perspective of users, data flow diagrams, database design, and prototypes to visualize preliminary and simplified version of the system. So for our results and discussions, we employed Python's Kinter to construct a user interface for the RFID reader module and installed the prolific plugin to ensure compatibility of RFID devices with the application. Visual Studio Code was utilized as the integrated development environment for creating and updating the source codes. And for the front end, we used HTML, CSS, JavaScript, and Tailwind CSS to create an interactive, user-friendly, and visually appealing interface. On the back end, we utilize PHP, Laravel, and for database management, we used MySQL. We performed a series of tests alongside coding activities. The unit tests were conducted rigorously on each module of the software component exclusively within the development team. Functional tests were also performed to identify problems arising from the integrated RFID reader and software components. We thoroughly tested RFID devices, GUI elements, user authentication, input data processing, batch inputting, error handling, database operations, report generation and management of routine herd operations, herd profiles, and user accounts. Following further refinements based on feedback from latter rounds of functional testing, acceptance tests were carried out to ensure the system met user expectations and was ready for deployment. The system features, we have the dashboard offering an overview of essential farm metrics, including the total number of goats, the death rate percentage, the count of kids, the sold count, visual representation of the herd population, and a breakdown of milk production per goat. It also highlights the most recent goat additions to the farm. Some other system features include MyHerd for individual goat profiles, menus for managing the goat farming operations, lineage tool for tracking of family tree up to the fourth generation, batch inputting to capture herd RFIDs during routine operations, setting of schedule for routine operations, the history for logs, system transactions, and the finance component for animal sale transactions. The system-based single and batch inputting methods, okay, show a time reduction of 42.7% and 65 or 64.5% respectively, compared to the traditional pen and paper process. So we have here the average time spent on the three recording methods. For the evaluation, we invited 5 IT experts specializing in networks and software development to evaluate the system. We adopted the ISO IEC 25010 criteria for assessing systems and software quality, with a scale from 1, which is the lowest, and 5 is the highest. The evaluation revealed a relatively high rating across all criteria, indicating general satisfaction with the system's functionality, overall performance, and compatibility with targeted processes. So, as a conclusion, the RFID-based record management system represents a significant step toward fostering a more efficient, data-driven approach to goat farming. It serves as an initial phase uh, in transitioning from traditional livestock management to a smart farming approach. The user participatory approach to system design has ensured integration into actual processes at the Small Ruminant Center at Central Luzon State University, highlighting its practical usability and effectiveness in improving herd management efficiency. Looking ahead, the system can be expanded with additional IoT-based smart sensors to monitor behavioral and psychological parameters of goats, enabling real-time health and vitality tracking. This would help farmers take early preventive measures based on illness or disease-related data. Feed tracking devices could also be integrated to analyze feeding patterns and historical trends in goat health. Additionally, incorporating data analytics and prediction models can enhance feeding and milking processes, offering insights into the relationship between feeding control and milk production for further optimization. Thank you very much, and thank you for listening to this presentation.